In 1971, the United States declared war on cancer. The president signed it into law. The scientists mobilized. The money poured in. Over the next 36 years, more than $200 billion were spent fighting this disease. $200 billion. And after all of it, after decades of research and fundraising and ribbon campaigns and celebrity telethons, the cancer death rate dropped by just 5%. 5%. But cancer's story does not start where you think. It does not start with a lab or a press conference or a president standing at a podium. It starts in the dirt of South Africa 1.7 million years ago, in the crumbling left toe bone of a creature that had not yet become human. Imagine the moment a researcher first held that fossilized fragment under a light, turning it slowly, and recognized what they were looking at. Not an injury, not a fracture, a tumor, growing into bone, doing what cancer has always done, what it was doing long before we had a name for it, long before we even existed to be afraid of it. Cancer is not a modern disease. It is not something we created. It is not a product of industry or processed food or power lines. It is older than our species. It is older than civilization. It has been with us since the very beginning, and the story of how we came to understand it, fight it, and sometimes beat it is one of the most extraordinary and troubling stories in human history. And this is the part most people never learn about. Go back to ancient Egypt. Around 3,000 years before the birth of Christ, before the pyramids of Giza were fully complete, a physician sat down and began writing. The document he created would survive millennia. It would be rolled up, buried, forgotten, rediscovered, unrolled with trembling hands, and read again by modern eyes that could barely believe what they were seeing. The Edwin Smith Papyrus is 4.5 meters long. It is written in hieroglyphics on material made from pressed river reeds. When you hold an image of it, you can see the careful marks of someone who was trying to make sense of something they could not explain. A bulging mass on the breast, hard to the touch, spreading. The physician described it with clinical precision, noting its surface, its size, the way it felt beneath the fingers. And then, at the end of the entry, he wrote 4 words that would echo across 3,000 years of medicine. There is no treatment. That was their conclusion. Not a theory. Not a proposed remedy. Just a quiet, devastating acknowledgement that this thing, whatever it was beyond them. The Egyptians who built monuments that still stand today, who performed brain surgery and set broken bones and understood irrigation and engineering and astronomy, looked at cancer and said, "We cannot touch this." That honesty would haunt medicine for centuries. The Greeks were the first to give cancer a name, and the name they chose tells you everything about how it felt to encounter it. Hippocrates, born around 460 BCE, the man we call the father of medicine, looked at tumors and saw something he recognized. When he cut into a solid mass, he saw veins radiating outward in all directions, reaching into surrounding tissue like the legs of a creature gripping the seafloor. He called it karkinos, the crab, not because of what it looked like on the outside, but because of how it held on, how it gripped, how it refused to let go. That word karkinos would travel through time, translated by a Roman physician named Celsus into the Latin word we still use today, cancer. And Hippocrates did not stop at naming it. He built an entire theory around what caused it. The human body, he believed, was governed by 4 fluids: blood, yellow bile, phlegm, and black bile. When those fluids fell out of balance, disease followed. Cancer, he concluded, was caused by too much black bile accumulating in one place, thickening and hardening and refusing to move. Treatment therefore meant purging the excess, bloodletting, laxatives, strict dietary control. It was completely wrong. But it was also an extraordinary intellectual leap for its time, replacing supernatural explanations with physical ones. And that is where everything changed. Because once people believed cancer had a bodily cause, they began searching for a bodily cure. For the next 2,000 years, cancer occupied a strange place in human society. It was known, it was feared, it was real, but it was also treated as something almost sacred in its terror. Something that marked the person who carried it as already lost. In the courts of ancient Rome, physicians who failed to cure a powerful patient of cancer sometimes faced execution. The disease was thought to be contagious by some, including a Dutch professor in the 1600s who believed cancer was a poison that slowly spread from person to person, that it moved through communities like a plague. In those same years, people referred to the disease in common speech not by its Latin name, but by an older, darker one. They called it the wolf. The implication was not subtle. Cancer did not just grow, it devoured. And for the wealthy and royal who could afford the best physicians, the best herbal preparations, the best treatments involving mercury and arsenic and burning hot instruments applied directly to the tumor, the outcome was rarely better than for the peasant who had no physician at all. There was a dark irony here. The treatments available for cancer for most of recorded human history were often more immediately harmful than the disease itself. Ancient civilizations used preparations of toxic compounds that could kill a patient faster than the tumor would. Surgical removal, attempted without anesthesia or any understanding of infection, produced survival rates so low they almost defy belief. The renowned Scottish surgeon Alexander Monro, in the 18th century, reported that of 60 breast tumor patients he operated on, only 2 survived longer than 2 years after surgery. 2 out of 60. But there was a problem beyond the surgery. The problem was that no one actually knew what cancer was. The breakthrough came not from a physician, not from a philosopher, not from a royal surgeon attending to a king's failing health. It came from a humble instrument that changed everything it touched. The microscope. In the 1800s, scientists gained the ability to see living tissue at the cellular level for the first time in history. And what they found inside tumors shocked them. Cancer was not a poison. It was not black bile. It was not a supernatural punishment. It was made of cells. Cells that had gone wrong. Cells that looked different from healthy tissue, that divided when they should not, that invaded when they should not, that spread through the body along pathways no one had previously mapped. In 1871, an English surgeon named Campbell de Morgan described the phenomenon that still defines our understanding of late-stage cancer today: metastasis. The way the original tumor sends its corrupted cells traveling through the lymph system and bloodstream to colonize distant organs, establishing new tumors far from where they started. And then, in 1902, a German zoologist named Theodore Boveri made perhaps the most important intellectual leap in the entire history of cancer research. He proposed that the chaos inside cancer cells was not random. He suggested that mutations in chromosomes could create cells with unlimited growth potential. He described the existence of what we now call tumor suppressor genes, the internal brakes that cancer destroys. He proposed that cancer could be caused by radiation, by chemical injury, by pathogens. He was working in 1902, before antibiotics, before television, before the airplane had left the ground. He was right about almost everything. This is the part that should make you angry. By the early 20th century, the scientific foundation was being laid for a real understanding of cancer. Researchers were connecting exposures to disease. In 1761, tobacco had already been linked to cancer of the nose. In 1775, the British surgeon Percival Pott had proven that chimney sweeps developed scrotal cancer at extraordinary rates because of their daily immersion in soot, establishing for the first time that a specific environmental exposure caused a specific cancer. The tools were there. The knowledge was accumulating. And yet the tobacco industry, which would go on to kill more cancer patients than any single force in modern history, spent decades burying that knowledge when it inconveniently pointed at their product. By the mid-20th century, researchers Richard Dahl and Austin Bradford Hill had published definitive evidence linking cigarette smoking to lung cancer. Their 1956 British doctor's study was unambiguous. It was not a suggestion. It was not a hypothesis. It was data from tens of thousands of physicians tracked over years, showing that smokers were dying of lung cancer at catastrophically higher rates than non-smokers. The tobacco companies knew. Internal research confirmed it. Scientists were paid to cast doubt. A prestigious scientific debate was manufactured where none genuinely existed. And while that doubt was being manufactured and sold to a trusting public, lung cancer rates climbed. They climbed for decades. Lung cancer, a disease that was rare before mass cigarette production, became one of the most common causes of cancer death in the world. Cancer did not just appear alongside the tobacco industry. The tobacco industry caused it, on an industrial scale, while knowing it. And the playbook they wrote, the strategy of funding doubt, of buying scientists, of manipulating public perception to protect profits, would be copied by other industries facing inconvenient research about their products for the rest of the century. But cancer's story was also changing in ways the old guard did not expect. In 1895, Wilhelm Röntgen discovered X-rays. Within years, Marie Curie and Pierre Curie had identified radiation. And almost immediately, physicians began experimenting with what radiation could do to tumors. What they found was staggering. High-energy radiation could destroy cancer cells. It could shrink tumors that surgery could not safely reach. It could buy time, and sometimes it could do something that seemed almost impossible. It could cure. This was the first moment in human history when something other than a blade had power over cancer. And it sent shockwaves through the medical establishment that were impossible to predict. Suddenly, the surgeon was no longer working alone. Oncology was becoming a team sport, requiring physicians and radiologists and eventually chemists and geneticists and immunologists all working together on a single patient. The age of multidisciplinary cancer care had begun. And then came something no one expected from a battlefield. Researchers studying chemical weapons during World War II noticed something disturbing about soldiers exposed to nitrogen mustard gas. It destroyed their white blood cells. Their lymph nodes shrank. And some researchers, looking at that destruction, had a grim but revolutionary thought. What if you pointed that destruction at cancer? In 1949, nitrogen mustard was approved as the first chemotherapy drug. By the 1960s and 1970s, combinations of chemotherapy drugs were producing something that had never happened before in the history of this disease. Cures. Children with leukemia who would have died within months were surviving. Patients with Hodgkin disease and testicular cancer were walking out of hospitals alive. For the first time in 3,000 years of medicine, the word incurable was becoming negotiable. But even as treatments improved, the scale of the problem was expanding in ways that made every advance feel insufficient. Today, cancer is diagnosed in approximately 20 million people per year around the world. By 2050, that number is projected to rise to over 35 million. Not because cancer is simply becoming more common, though lifestyle and environmental factors play a growing role, but because the world's population is aging, and cancer is, above all else, a disease of accumulated time. More than 3 out of every 5 cancer diagnoses happen in people aged 65 and over. It is in your family. Statistically, it is almost certainly already in your life in some form. 1 in 2 people in many developed countries will receive a cancer diagnosis in their lifetime. 1 in 2. And here's what makes that number even more complex. We still do not know exactly how cancer starts in most cases. We know risk factors. We know carcinogens. We know that inherited mutations in genes like BRCA1 and BRCA2 dramatically elevate certain risks. We know that HPV causes the majority of cervical cancers, which is why the HPV vaccine, introduced in 2006, has already begun producing a measurable drop in cervical cancer rates in the countries where it is widely used. But the fundamental question of why a specific cell in a specific person's body decides, on a specific day, to stop following the rules, that question still does not have a complete answer. And 45.5% of all cancers worldwide were still being diagnosed at an advanced stage as recently as 2018, when treatment is harder, outcomes are worse, and the distance between diagnosis and death is shorter. The cancer is there. We just are not finding it in time. What the last 50 years have produced, though, is something genuinely extraordinary. Something the physicians of ancient Egypt and the Greek philosophers and the royal surgeons burning tumors with hot irons could never have imagined. In 1984, Harold Zurhausen discovered that specific strains of HPV were directly responsible for around 70% of cervical cancers. He won the Nobel Prize in 2008. In 1986, the first immunotherapy was approved, a drug that helped the immune system recognize and attack certain cancer cells on its own. By the 1990s, targeted therapies were being developed that attack specific molecular features of cancer cells rather than poisoning everything in the body that divided quickly. In 1998, trastuzumab was approved, a drug that blocks a specific protein driving certain breast cancers, turning a particularly aggressive subtype of the disease into one of the most survivable. In 2000, the Human Genome Project was completed, giving researchers a map of the entire human genetic code and opening the door to a new era of personalized medicine, where a patient's tumor could be analyzed at the molecular level and a treatment selected not based on where the cancer was in the body, but on its precise genetic identity. As of 2022, more than 18 million cancer survivors were living in the United States alone. That number did not exist 50 years ago. It was not possible 50 years ago. Cancer's story spans 1.7 million years, 6 continents, and virtually every chapter of recorded human civilization. It was there when the first Egyptian physician pressed his fingers against a swelling he could not explain and reached for his reed pen. It was there when Hippocrates named it after the crab and built a theory around what moved through the body like salt water through sand. It was there when Percival Pott watched chimney sweeps grow sick and finally connected the soot to the cancer and changed the way medicine thought about cause and effect. It was there when the tobacco companies sat in boardrooms with their own research and decided profits mattered more than the people buying their product by the millions. It was there in the chemotherapy wards of the 1970s where children who should have died were instead going home. And it is here now, in your cells, in your DNA, in the small mutations accumulating quietly every time your body divides and repairs itself. It is in the food systems you navigate every day, in the air you breathe, in the choices being made right now, in laboratories and policy offices that will determine whether the people sitting in waiting rooms in 2050 have more options than the ones sitting there today. Cancer waited 1.7 million years for us to understand it. We have not finished yet. Cancer persists. Cancer evolves. Cancer adapts. And it is in your body right now, held back by systems of repair and suppression that took millions of years to build, waiting to be noticed.